I'm a teacher from Serbia. I teach in primary and secondary school, and I'm also a PhD student currently ending exchange program here in Linz. And field of my research is creative approach or approaches in STEM education, and today I will present one of them which combines origami, mathematics and technology. Maybe you have seen this picture on Facebook or somewhere on the social media, which depicts how the future of education looks like, because we in school as educators have a very hard task to prepare students for the future. We don't know how it's going to look like because the technology is developing so fast that we don't know even which kind of jobs there will be or which kind of skills there will be needed. So we really need to focus on many things to provide students different kind of knowledge to prepare them for the future. Personally, I have some kind of a vision for future education, but as I'm only a teacher and a PhD student, not many people care about my vision, but so that's why I took this quote by Michio Kaku. He is a Japanese origin American physicist and a futurist, and he many suggestions about how education will look in the future. So the stress is going to be on concept and principles and not so many on the content. So students, the education will look completely different. Students will learn outside with different supported with technology, and teacher will be there to guide them. What are innovative approaches? They consist of visualization, wise use of technology tools, not just using technology because it's like a nice thing to do, or we have a lot of computers or devices, but to just give that technology some meaningful point, and active learning, peer instruction, discussion, groups, collaborative problem solving, and so on. So today I'm going to promote one of these kind of approaches that is innovative and that match before mentioned characteristic of some kind of a future education. It's an approach that combines mathematics, origami, and technology. And it can be used in primary and secondary school to convey different kind of mathematical and scientific concepts. During my stay in Linz, we have developed some kind of framework that how to combine these three at the first sight unconnected things. So maybe some of you knows or are familiar with that origami is practically a mathematical discipline. In about end of the 20th century, it was established as part of mathematics because it is axiomatized. There are axioms, origami axioms, like the Euclidean axioms, and they solve many scientific and mathematical problems, even that one that wasn't solved for centuries, such as doubling the cube problem. So as it is proven, origami is proven very powerful scientific and mathematical tool, can solve quadratic equation, cubic, quadric, or any. It is also used in nanotechnologies, in the technologies related to the engineering, and so on. So we have this path from inventing paper and joyful activities such as folding paper cranes to the space satellite, which is also folding and unfolding on the origami principles. This kind of folding is known as Miura Ori. It is also a Japanese physicist who developed this kind of folding, and it's also maps can be folded by this principle. So, besides its place in science and mathematics, it also can be used in education. There are growing publications that support that theory, especially in the topics related to geometry, but also some algebra or some other concept can be conveyed through the origami education, origami activities. I started about 10 years ago with applying origami in my classroom, and it kind of developed now to the whole approach. So firstly, we started with high school students, and for example, how does those lessons look like? For example, when we teach about Platonic solids, its properties, students fold from paper and then explore with the GeoGebra. So we are connecting virtual and real life that students are surrounded. Or, for example, we used fractals to explain some topics in the second grade of high school, like logarithms, because fractals has this different kind of dimension, which is calculated by logarithms. So it was excellent way to connect something very new in the mathematical discoveries and something that students learn in every day, which is also covered with curriculum. And we went one step more. We introduced programming in Scratch, where we used these kind of activities to make students to understand the concept of recursion, for example. So they have already programmed this fractal. It is called dragon curve, and then they were analyzed, and we were going like backwards to convey this concept of recursion. As those results was very good, they inspired us to go further. We applied also in the primary school, which is a little bit more even challenging, because students have limited mathematical knowledge. So we use origami to convey, to teach them basic geometrical notions and basics of GeoGebra, because that was the first time that they had the opportunity to learn GeoGebra, and it was very good experience, and we got different kind of results that we are using in furthermore in developing this concept. And at the end of this presentation, I would recommend you and recommend to your attention the chapter in this book, Handbook of the Mathematics and Art and Science, where I wrote these basics of origami as a math and art discipline. So this would be in the short lines what is one of the fields of my research is.
Some questions?